Okay, so the last video was just a bit of nuts and bolts about how to do algebra for the physics course. Now we're going to get started in the course properly. So physics, the goal of physics is to try and understand the rules of the universe. How do things work and why? And to do that, we're going to need to know about quantities. Okay, so physics deals in things we can measure. Anything that you can find a value for, measure in some way, we call it a quantity. So the mass of an object is a quantity, the speed it's travelling at is a quantity, how much energy it contains. These are all quantities, okay? And they're useful because, as I say, we can do something with them. We can put a number on them. If you can't measure it in physics, we don't really care about it. If you can't measure it, it probably doesn't exist, or at least we haven't discovered it yet, okay? So we'll be using lots of these throughout the year. But right at the start, we need to make a distinction because there's two kinds of quantity. There's scalars and vectors. So quantities, as I said, are anything you can measure. Well, why do I have two camps? I'll give you an example. Let's think about the mass of an object. How much stuff is in it? Okay. But compare that to the force. So if you've got a mass of an object, but then that object is pulled with some force. They're both quantities. They're both things I can measure. I can measure the mass of an object, and I can measure. I can use that with a spring balance. I can measure the force of an object. I can measure that with the spring balance. But they're kind of different in a fundamental way. The mass isn't pointing anywhere. Mass is just the mass. Whereas force only makes sense if it's moving in a direction. Okay, you can have a mass of 1 kilogram just sitting there, but you can't have a force of 1 Newton that isn't going anywhere. Force, by definition, is a push or a pull. So we have to treat these kinds of quantities quite differently when it comes to solving problems with them, because this one has a direction inherently and this one doesn't. Okay? So any quantity, that has no direction is a scalar. We call it a scalar. So mass is an example of a scalar, and scalars have size. The posh word for size that we're going to use in this course is magnitude. So it's got a size, it's got a magnitude. But that's all it's got. Okay? So a kilogram, it doesn't make sense to talk about mass pointing anywhere. 2 kilograms to the left doesn't really mean anything. Whereas the vector here, it doesn't make any sense unless you include direction. So vector has to have magnitude, has to have some size, and it's got to have a direction for it to make any sense. Okay? So the first vector we're going to see is force, but we're going to add to them as we go through. I'm using force because it's the one that's kind of the most intuitively, obviously, it's got a direction. Okay? So we can make a wee table of some of the quantities that we've known. Most of the quantities we've used in the BGE science are not vectors. Most of them are just scalars. So the scalars we've seen, and I guess the question to always ask yourself is, does it have a direction? Can time point different directions? No, it can't. Time's a scalar. We said mass can't point anywhere, it's a scalar. The distance you travel, when you say, oh, I just ran 5 kilometres, no one asks you 5 kilometres where, you just say, okay, you ran the distance of 5 kilometres. And so if distance is a scalar, then speed must be too, because speed is just distance divided by time. That's all speed is. Okay. Others that you've seen in it before would be things like temperature, would be things like energy. Energy doesn't point anywhere. So again, most of the and then this list goes on, most of the quantities we've seen are all scalars. The one I've given you so far is force, but we're actually going to come back to that in the second topic. We're going to look at motion first, and we'll look at the forces that cause changes in motion later on. I'm going to give you two new ones for now, two new vectors, because it said you travel 5 kilometres in a race, no one asks you where you went. Well, unless it's like an orienteering race, say it's Duke of Edinburgh and you're trying to go from point A to point B, so distance might tell you the length all the way around a running track, that'll tell you your distance D. But say you're orienteering your Duke of Edinburgh, well, you don't just want to go around in a loop. It's not just how far you walk, it's where you need to start at point A and you need to get to point B, which is, home, right? So here direction really does matter. If you're up a hill and there's a cliff on one side, where you go matters. So there we need a vector. We need a vector that includes the how far apart A and B are, but also what direction to go from A to get to B. We've got a name for that, we call it displacement. Okay? So when we care about direction, we use displacement. When we don't care about direction, we just care about size only, we use distance. And just as distance divided by time gives you speed, well, what displacement divided by time? That can't give you speed, it needs to give you a vector. So we need to add a new thing, a new quantity we haven't seen before. It's a word you've seen before, but we haven't used it right before. Velocity, okay? So velocity is when you consider direction too. How far along this line from A to B do I go each second is your velocity, okay? So that's all we're going to leave it for now with vectors. The next video will be how to add them. But first of all, I just wanted to make a quick video about the difference in scalars and vectors and get some practice looking at how would you split, well, what kind of quantities are scalars, what kind of quantities are vectors.